With the permission of the Council of Deans and in order to obtain the degree of doctor from Radboud University in Nijmegen, I would like to defend in public my doctoral thesis entitled Focusing on the Individual Infant, Classification and Heterogeneity of Autism Spectrum Disorder. Autism Spectrum Disorder, or ASD, is a group of neurodevelopmental disorders characterized by social communication impairments, restricted repetitive patterns of behaviors and interests, which also include sensory abnormalities. ASD is one of the most common neurodevelopmental disorders, with an estimated prevalence of about 1 child in 59 children in the US. And if we look at the functional outcome in adulthood, the recent review has shown that about 48% of adolescents and adults with ASD have a poor or very poor outcome, which means that they require substantial support or even residential care. The best prognosis for ASD currently lies in early targeted interventions aimed at improving such later functioning, but research suggests that such intervention has to occur in a timely manner, possibly within the first few years of life. And although we know that ASD, the trajectory to ASD, already begins in pregnancy, the average age of diagnosis is about 3 years or even later, which leaves a huge gap and delays access to intervention. So research has focused on investigating the early manifestations of the disorder and have identified early signs and precursors, for instance, looking at the temperament or motor behavior, cognitive behavior, and adaptive functioning, but also more social behavior like looking at the faces. And to do so, they use the so-called high-risk design. So a child is considered to be at high risk for autism based on having an older biological sibling with ASD. And in fact, these high-risk siblings have a higher likelihood of developing ASD compared to the general population. So high-risk siblings and low-risk controls are recruited and followed up longitudinally until they receive a diagnostic outcome at 36 months. And then we can define 3 groups: the high-risk ASD, non-ASD, and the low-risk controls. And then we can look back at the data to see whether groups differ really early in development. And although useful, such group comparisons do not really tell us anything about the individual infant, as there is a huge overlap of groups and individual variation. So for my project, I've been focused on individual prediction of ASD. And to do so, I used supervised classification approaches, which means I have a group of high-risk siblings. I know those who received an ASD diagnosis and those who didn't. And then the algorithm learns a way to separate the 2 groups. Then I fill the algorithm with new individuals, and these would tell us whether each individual is going to develop ASD or not. And I did that for 3 separate studies. In the first one, I used measures of cognitive and adaptive functioning and early symptoms at 8 and 14 months. The second one, I used measures of temperament at 8, 14, and 24 months. And in the third one, I used measures of neural processing of faces at 8 months. And the results showed that in the first study, the best predictor was daily living skills at 40 months. That provided moderate accuracy, but there were a lot of false positives. And the same happened in the second study, for which the best predictor was effortful control at 24 months. But it was the third study that provided the best predictor, which was narrow sensitivity to faces and visual noise at 8 months, that provided both good accuracy and good specificity. But what does it mean? So we show the infant faces with direct gaze, averted gaze, dynamic gaze shifts, and visual noise, and recorded neural responses while looking at such stimuli. And you can see here on the right an example of the neural response to the stimuli. And what my study says is that subtle differences in both the intensity and the timing of response to these stimuli, in particular to the faces as opposed to visual noise, can help discriminate ASD from non-ASD siblings already at 8 months. Although useful, the supervised classification approaches still rely on the concept of clinical categories. But we know that ASD is a very heterogeneous disorder, so there is a high variability in onset, in presentation, symptoms, severity, so we can rather define subgroups than considering ASD as a single predefined category. So I moved to data-driven methods, which means that I did not rely on the clinical categories anymore, but I tried to find the structure in the data. And in the first study, I did that to identify subgroups. In particular, I found 3 separate groups of longitudinal development of adaptive functioning, one group with decreasing, one with increasing, and the other one with stable adaptive functioning over time. And what's interesting about this study is that the three groups did not clearly map onto the clinical categories that we showed before. For instance, the red group is the one that had the higher likelihood of developing ASD and higher levels of symptoms, but at the same time there were ASD siblings also in the other trajectories. So these groups might actually be more relevant target groups for intervention. And then in a final study, I used the data-driven methods to identify underlying mechanisms. If we think that there is a mechanism, latent mechanism for ASD, it likely acts on different levels and on different functional domains. So I integrated, in particular, measures of cognitive and adaptive functioning to ASD symptoms, and I found one longitudinal mechanism of increasing competence linked to low levels of symptoms, and this was more expressed in so-called typical development. In fact, you can see that the yellow dots in here show the level of expression of the mechanism within the individual infant. And then I also identified a second mechanism that indicates a stagnation or even regression of cognitive and adaptive functioning, which was linked to a higher level of symptoms and present more strongly in atypical and ASD groups. And finally, I linked these measures to the neural sensitivity to phases at 8 months only, and I showed that the profile of good competence and low levels of symptoms was linked to better processing of perceived gaze shifts. And it was more present in low-risk and high-risk typical siblings, but there was still a huge overlap between groups. So the take-home messages from my project, well, we confirm that brain data outperform behavioral data in prediction of ASD in the first year of life, and in particular, it was a diffuse pattern of alterations in neural processing of faces and visual nodes at 8 months to predict ASD outcome at 36 months. Then in the second part, identify subgroups that might be more relevant target group for intervention. In fact, the aim of the intervention might be to improve later functioning, so subgroups identified based on functioning might help targeting such early interventions. And finally, identified mechanisms that act together early in development in the individual infant, and based on their level of expression within the individual, they can lead to a different outcome. And the common theme of all these studies was moving from the level of the group to the level of the individual infant to allow early detection and investigation of heterogeneity of ASD.